All right, so today we're going to continue to talk about classes. I have it on the schedule here, and so we'll spend one more day on this. And I know it's a difficult part of the course. Usually everybody is confused at this point. And the key there is to study the code that I present, to study the code in the book, to study the sample code that I have online here in the form of exams, and practice programming with these classes. And then you'll start to get a feel for it. So you've got to do it. You can't just read or just listen. You have to do. It's very important to practice this. And last time I mentioned that I had presented everything that we needed to know about classes, and I forgot a few details. So I'm going to cover those right now. It's not a lot, just a little bit. So we had this file here. Let me get rid of this other stuff. So you have a file main, and this is not the organization that I'm asking for in the assignment. So in the assignment here, so I give you the test code to use. So this would be, ex1.cpp. And here I say your solution should have 3 files. ex1.cpp, and that contains exactly this code right here, unchanged. And you'll see it's test code. And look, we're including number.h so that this number class is not defined in the same file that main is defined in. It's defined it's declared in a separate file called number.h. And we use an include statement to copy that header file, the contents of the header file, to copy the contents of the header file into this file. And that's actually what this does. This is like a copy-paste operation. So if I say include number.h, the compiler looks in the current folder and finds a file called number.h, takes its contents, copies it, and pastes it right here. And then after it does this pasting operation, then it compiles the code. So it's like it's just a stage in the compilation process. And what does the code do? Well, there's a main function that's the entry point to the program. That's where execution starts. We create an instance of the number class. We call the instance 9. It's a good name because it represents the value that the object is going to represent. We're passing in the value 9 here. That's stored internally in this number class. And then we call 2 different functions on it, is prime and is divisible by. Is prime returns true or false. It returns true if the object represents a number that's prime. It returns false if the object represents a number that's not prime. So 9 is not prime, and so if we call this function 9.isPrime, it should return false. Now if we had assert 9 is prime, that assertion would fail because this expression I have highlighted right here evaluates the false. So we use the not operator here to negate the negation operator, to negate that false value and turn it into true. So when that means the resulting expression, not 9 is prime, that expression evaluates to true. That's passed into assert, and then assert just quietly terminates, and then the next assertion runs. And the next assertion, it's similar in that the function that we invoke against the object, 9.isDivisible by, that this function returns true or false. It returns true if the value passed in to the function evenly divides into the number that the object represents. The 1 evenly divides into anything, so that will always return true. But 9 is not divisible by 2, so we're negating the result here to convert it to true, so the assertion just succeeds. And then we test some other numbers. We test 7, 20, 77, and 27, so on. No, 70, 73 rather, and 27 here. And if we pass through all these assertions without getting a failure, it's an assertion failure, then we'll print all tests passed. The last line here, see and get, what this line does is it pauses and waits for the user to hit a keystroke. And we need that when you're running the program in debug mode in Visual Studio. And most people are not using Visual Studio, so in that case, you can just omit that line. You can leave it in there too, it doesn't matter. So now this is the contents of that file ex1.cpp. It's the test code for the number class. Now your job is to implement the number class. You put the class declaration in number.h. You put the implementation of the functions in number.cpp. You don't have to do it that way. This is just one way to organize the code. But I ask you to do it this way because this is the most common way that people organize this type of code. So this is the typical organization. So I wanted you to become familiar with the typical organization. Although you do see what I have here, everything in one file, you do see that as well sometimes. And one other thing what we didn't cover, I'm asking for a UML class diagram within a multi-line comment in number.h. And I want to show that to you today. So let's do all of these things. First, what we'll do is we're going to split out the code into these 2 additional files. I'm going to start by copying this to number.h. So I'm going to make 2 copies of this. And this is main. So main, we don't need the definition of bean jar here, or its implementation of its functions. Instead, we'll include the header file. This is what declares the class beanjar and declares all of its properties. So when the compiler copies that declaration in, it knows that this constructor is defined. It doesn't have the definition yet. That's something that's resolved at linkage time. Yeah.
So like the is divisible by and the stuff like that was in the assignment that was in.
Oh, I'm sorry. This should be beanjar. Yeah, I'm not solving the lab assignment. Thank you. This should be beanjar. Yeah, I'm doing the wrong problem here. So I'm showing you how to solve the problem with beanjar. You have to solve the problem with the number class. Okay. So look at what I'm doing. Try to understand what I'm doing, and take that and use that sort of pattern to figure out how to implement the number class. So you would have, include number.h here. And this code right here, that would be pasted into this file here. All of this whole file. And you'll see that code there includes number.h. So this is a parallel problem we're solving here. So here we have beanjar.h. Oh, I called it number, didn't I? Sorry about that. This should be beanjar.h. And And, oops, made a mistake there. These are case sensitive. This should be uppercase being jar, that's camel case. And same with the header file. And that's the convention. So the file name is I've got using the same name as the class name. It's not required in this language. In the Java language, it is required. I don't know about C#. I don't think it's required in C#. The Java language requires this. So it's not a convention in the Java language. It's part of the language definition. It's required. It won't compile unless the file name matches the class name exactly. But here we're just doing it because it's good documentation. It makes it the code more readable. So let's look at the header file. Well, let's create the header file. And I don't think I need that. So the header file contains just a declaration. Right there. But there's something else we put in the header file, because sometimes header files include other header files, and those header files turn around and include the original header file. So you get cycles. Get these include cycles. And the compiler doesn't handle that. So we have to break these cycles, and we do it like this. Pragma once. And we tell the compiler, hey, check to see if you've included beanjar already. If you have, then just ignore the contents of this file. So only include this once as you process a given compilation unit. Compilation unit is a file, basically, in C++. It's one of those implementation files. It's like a something.cpp. A header file is not a compilation unit. Anything that ends with .cpp is considered a compilation unit. And this is saying that only include this declaration once when you're processing the compilation unit. This is the new way to do it. I think basically all compilers support this now. But you may see old code. And old code does it like this. If ndef, which means if not defined, something, just anything, but you can use something that makes sense, like beanjar with underscores and an h. If beanjar.h is a variable that's not defined, if ndef, if bean underscore jar underscore h is not defined, then include all of this. And if it and when you do include all of it, let's define bean jar h. This is the way you see it in old code. So this has the same effect. So the first time the compiler passes through this code, it processes this statement here. It says, oh, is the variable bean jar h defined? Is this label defined? I'm not going to call it a variable. I don't want to confuse you. It's not like a max beans variable. It's a different type of thing. They call it a macro. It's something that's used in the pre-processing phase of compilation. So if bean jar h is not defined, then include everything all the way up until the end if statement. And so what does it do? To include everything, well, it has the first thing it does is it sees another pre-processing directive. These statements, or these directives that start with a hashtag, that's what they're called these days, that this indicates a pre-processing directive. So this is an instruction to the preprocessor of the compiler. Before compilation proper starts, do some initialization first. Execute these pre-processing directives first. This directive says, hey, the label beanjar h is not defined, so go ahead and define it. And I think in a very old code, they would do something like that. It actually set it to something, bean jar H is set to 1. But that's not needed. So I think you typically see it like this. And then all of this business in here is included. This is, and then the second time this thing is included, the preprocessor reads this first line again. It says, if ndef, that means if not defined bean jar H. But it says, oh, wait a minute, bean jar H is defined. So I'm going to skip over everything because it is defined. It's not, you only go into here if it's ndef, if it's not defined. If it is defined, you just skip over it. And that's what breaks that circular include. So you can do it either way, or it's simpler, just do pragma once. Hashtag pragma once. That's the current way to do it. But you'll see, I'm sure you'll see old code if you're working in this area. You'll see old code that looks like this. All right, so bean jar H is defined. What about the bean jar? The bean jar implementation file. Oops, that's not right. The bean jar, just like the main program, or the file, just like the compilation unit, the CPP file that defines the main function, the entry point, we also have to include beanjar.h. And then what we just do is go down through all of the functions and provide their implementations. What I mean by that is declare the function like this, this function signature, we can call it. And then after the function signature, then include a block of statements that comprise the function's implementation. The block of statements starts with an opening brace and ends with a closing brace. And everything between the opening brace and the closing brace are the statements that are attached to that function. And you'll see the brace, of course, is also used in here as well to create that same kind of organization where you have substatements under a parent construct. And so just go down, this main, now we copied from the old code, so we have to take this out. This is already defined for us. So there it is. That's that's it. That's the whole file right there. This is the constructor. You know it's a constructor because the function name is identical to the class name. That's a requirement for constructors. Yeah, question.
And this file is called beanjar.cpp.
Beanjar.cpp, that's correct.
And what are we going to put in the .h one?
In .h
What does that feature show?
Is the declaration. Okay. It's class, beanjar, public. You see the function here? That's a constructor. Add beans is here. These are declared, but look, we don't have the block of statements that are attached to the functions. But the compiler doesn't know. It knows that you said that these functions exist, and you've given their signature, what they look like, what they take as inputs, what they produce as an output. But the compiler at this point doesn't know what the operations are that it needs to run when the function is invoked. That's provided in the CPP file. But this is called a declaration, and this is a header file. The header file is simply a declaration of functionality which is defined elsewhere. And it has to do with the way the compilation works in phases. The first one phase is compilation, where you generate this object code. And then there's references to functions that need to be invoked in this object code. And then the linker pass runs. And it follows those references out and finds the code that needs to run at those times when the functions are invoked. and it does some wiring to make sure that happens. Remember we looked at that linkage failure last time. Is a linker command is LD on Unix systems, like Mac is a Unix system. There it is. There we have it. Beanjar.cpp, beanjar.h, and main.cpp. Of course, you're going to do something like, ex1.cpp. That's how your lab 1 will be organized. I mean, your first exercise of the lab. What does the lab say to do? Oh, yeah, that's exercise 1. Exercise 2 is something else, and exercise 3 is something else. All right, let's see if this runs. Now watch carefully here. I'm going to do it wrong on purpose. C++ main dot, oh, not main, ex1.cpp. What is the problem? Look at this down here. You see it? The hint LD. That's the linker. So the compilation phase succeeded. It said, oh, all the names make sense. Functions are called correctly. There's no syntax errors. But the linker, so the compilation phase has succeeded, but the linkage phase has failed. It's saying here, oh, wait a minute, undefined symbols. You told me that remove beans takes an int and returns a bool. I'm okay with that. You told me about that, so I could compile the code. But when I went to resolve that function, when I went to actually wire it up so that it ran, when it was called, I can't find the definition for it. Because the definition is in this beanjar.cpp file, which was not included on the command line. We have to include that on the command line with ex1.cpp. We have to get both compilation units to be compiled and produce object code in order for the linker to succeed. See that? That runs. Now a.out is produced. By the way, just to see that, we can tell the compiler, don't, first look at the contents of the folder. There's a.out. I'm going to remove that. There's 3 files there. And I'm going to tell the compiler, just compile, don't link. -C, just compile, don't run the linker. All right, see that? I think we did this before. And now if I do ls, I see, oh, the object code, beanjar.o, ex1.o. And I don't know what the linkage command is to get these. I don't think this is right. I don't know how to do it. So I want to do the whole thing in one shot, including linkage. I'll do it like that. It should work. Let me see if I can get it. It should be just something as simple as this. What's going on there? So, oh, maybe it's like something like that. I think that's what did it. Watch this. So if I do this, it finds those, that runs it. So, that works. Anyway, that's it. But there's one more thing we need to do here. Is is document this class using the Unified Modeling Language, UML. And we're going to, the UML is a sort of a group of, it's a standard that defines different diagrams, different types of diagrams that are used to document source code. And one type of diagram is called the class diagram. And the class diagram is intended to give programmers a quick and easy view of what the class looks like. Let's go ahead and do that. And I show down here an example. So I'm using this. See, this is the class diagram for this egg carton class. And this class diagram has 3 sections in it. It's a box, and it has 3 areas. The top area contains the name of the class, egg carton in this case. And the second section are the member variables. And the third section are the member functions. And notice this symbol out front here. This means that this item is private. And the plus sign down here means this item is public. Now you can have public member variables. They don't all have to be private. They just happen to be all private in this case, which is typical. The member functions don't all have to be public. Some can be private. These just happen to all be public in this case. But you could have minus signs down here as well. Remember, the bottom section are all functions. The middle section are the variables. Top section is the name of the class. So to document this class, this bean jar class, we do something like this. Bean jar. And the bean jar has an integer called max beans and another integer called beans. Max beans are the maximum number of beans that the jar will hold, and beans are how many beans are currently in the jar. And this is the constructor for the egg carton class. Let's turn it into the constructor for the bean jar class. That's max beans. This is beans. And this is it get beans? And down here it looks like get beans. Let's put it right there. I know there's a get beans function. I think there is anyway. Is there get beans? Yeah, there's get beans. Get beans returns an int. Get beans. So the syntax is a little different. You have the function name, the arguments, colon, return value data type. So you don't put the int in the front, you put the int after the function. And add beans, the name of the function comes first, the data type follows. Bool, and add beans is bool. See it down here. And it takes as an argument a number of beans. And the arguments also have data types. So there's similar to showing the data type for the return value of the function, the parameter data type is shown following a colon, following the name of the parameter. We have beans, colon, int. And this will be, was it remove beans? Yeah. This is how many beans to remove. And just clean that up a little. So there it is. That's the UML class diagram. I asked you to put it inside beanjar.h. So On the exam, I may give you the UML diagram and ask you to implement the functions. Or I may show you a declaration of a class and ask you to draw the UML diagram. So you have to sort of memorize the how the diagram is set up. It's not tricky, you just have to memorize it. Because once you have the declaration, it's straightforward to generate the diagram, or vice versa. All the information is there to go in both directions. This is a multi-line comment because we're using /* to start the comment and */ to end the comment. Are there any questions? Once again, it's going to be hard to grasp this unless you do it. Stare at the code and do it yourself. You've got this problem to do, the number class. And then you have another problem, listing prime numbers with the number class. So use the number class. Third exercise, this egg carton class, implement this. And so you need to work on those and submit those by Friday or Saturday, I forget the day. The deadline's Friday, right? Friday night. And then, the exam that's coming up. This block of previous exams, you can look at those as well. There's Bean Jar, that was an exam problem. And here's a class called integer. This is similar to the number class that you're implementing for the lab. And some extra credit there. That was last spring. Last winter, I asked to implement this class called fraction. That's similar to the integer problem or the number problem. And what else did I ask here? Yeah, this was a lot to do on that one. And in fall, 1 year ago, I asked a bean jar class again. And that's all I asked, was just that. And then on the final exam, this is last spring. This is the final that I gave in spring, last quarter. Oh, the number class. I use that on the final. That's the problem you have to do. But I put in functions that do I have is lucky in this one? No. Well, I added is lucky here. So you can do lots of variation on these things. So this is on that final. So the number class is asked on the final exam last quarter. And 1 year from this quarter, let's see, the number class again. I think a slightly different version of it. And then winter. Number class again. So I'm using that one a lot. So I won't ask that this time. I think I had one, you don't see it here, I had one, a school bus. Maybe I'll ask the school bus problem. So before these quarters, I had students implement a class that represented a school bus. You have maximum number of seats. You have the seats on the school bus, how many students are in the school bus. Add students, remove students, like that. So did you have a question? Yeah.
What if we put the
Header file, the declaration.
so in the header file, what if we have the public members like under the class in the header file?
So here's the header. Let's look at the header file here. So different from this, you're suggesting, or you're describing a situation that's different from this?
Yeah, so in my header file, I declare the class bean jar, and then under the class, I put all the public members under that. And
What do you mean? Like, you mean down here?
yeah,
There?
yeah.
No, that won't work. It has to be inside. It's got to be in here. Somewhere in there. This order you can play with. You could do it like this. This is all right. But it's got to be inside these two braces here.
No, I mean like the code that accompanies the.
Oh, the code. Oh, you stick it in the header file. Yeah, I mean, you can do that, but that's not the organization that I want you to practice, but you can do that. For instance, this bean jar constructor could look like this. So you could put the definition of the constructor right inside the declaration block. You can do that. Of course, this will be a problem. So what we need to do is take this one out. So we don't get a conflict. And now it's still okay. So that's possible to do it like that. You can do it like that. Another way to do this constructor is to use what's called an initialization list. So max beans, so you put a colon here. I'll show you another way to do this. Put a colon here, and do the variable max beans is set to something, say set it to 8. And beans is set to something, say you set it to 0. Then open and close the implementation block. But you don't want to set max beans to 8. You want to set max beans. So this is the member variable max beans. You don't want to set it to 8. You want to set it to the max beans that are being passed into the constructor. So you would do it like this. Same with beans. Oh, that should be beans. So this is another form of the constructor. But actually, and I'll show you that compiling. And this is pretty common. This is the most efficient way to do it, by the way, this one right here. But we could also put it in this file as well with that format. So this is okay. But then we got to declare that as being in the bean jar class. And I want to be consistent with my formatting, so maybe I'll do that. And what some people do is they drop this down on the next line, just to tighten it up, like, well, so it's not stretched out so far. And then this would have to be, returned back to a declaration again. So that also works. So lots of variations. The way you organize the files can be varied as well. But I want you to practice the classic approach, just so that you're familiar with that. And these variations, I mean, you can practice those as well. But I did, in the exercise, I did specifically ask for that organization. So if you can follow that organization, that will assure you of getting full credit, because, Sushmita is going to be grading this, and she's going to read the problem statement, and she's going to notice that you have not solved the problem according to the problem statement. So I would do it according to the problem statement. But on your own, as you're testing, like maybe you're coding up some extra problems, practicing for the test, then you can do it in these other ways. You got a question?
Yeah. Do we need to use the hashtag include number.h on both the implementation and the test code?
In the implementation code and the ex1.cpp?
Yeah, like on both of
You
them.
need them in both. Yeah, they both have to be there, and let me show you why. Because if this is out, then we're saying, oh, in the bean jar class, the bean jar constructor is defined as follows, and the compiler is going to say, what bean jar class? You're defining a function for a class that the compiler doesn't know anything about. What bean jar class? Use of undeclared identifier, bean jar. So that's needed there. The same here. And if we take that out, we're going to go down to there, and it's going to say, what bean jar class? Or what's bean? Not even class. What identifier? Undefined identifier, bean jar. Unknown type name, bean jar. Well, it's a little different. They said they know it's a type name because of the way it's used in the code. See, what does that mean? Type name, type. They mean data type. Remember, what we're doing is user-defined data types. A bean jar is our data type that we've defined ourselves. And it's saying unknown type name. They mean unknown data type name. Type. What is the type of the variable? That's short for what is the data type of the variable. What's the type of data that the variable represents? So bj1 is the variable. An instance, it's an instance of the bean jar data type. Like we're instances of humans, but your dog is an instance of dogs. Right? A different kind of a pattern, or a class of things, and you're an instance of this class. That's where the word came from, class. You have an integer, 9. X int x equals 9. X is of type integer. It holds integers. It represents a specific instance of that type integer. Any other questions? Yeah.
I sent in the lab already on Monday. Can I just ask to have it regraded if it's already been graded?
Did you check your grade?
I haven't.
Yeah, check your grade and talk to me later about it. Okay, at the end of class, I'll handle that. Yeah.
Can you go over the number, like the class number thing?
Oh, number?
Yeah.
So in the specifically right here, right?
Yeah.
Let me show you how to get started on that. Let me get rid of those object files. So let's so we have nothing in here. So we need to create a file called ex1.cpp. This is what you'll do in lab or at home, whatever. Just copy this stuff. Copy this code. Paste it in there. Save that. Now we have ex1.cpp. We don't need to change that. That's done. Now let's create number.h. Remember the pragma once. The code will run correctly without this, by the way, but it just should get in the habit of doing this. So we're defining a class called number. And remember that the class definition, or declaration rather, is inside this statement block. And the statement block is followed by a semicolon. That's a common mistake, is to leave that out. Unfortunate that the language requires that. It's an old language, and newer languages don't have those idiosyncrasies. There's a public section. There's a private section. In the public section, it's going to have a constructor that's going to take an integer. The private section is going to declare the variables. Well, you'll have to store at least an integer. That's, instances of your class represent integers or numbers. Well, integers, not floating point values. And there's the beginning, and then there's a bunch of functions here. What's it? Is prime that returns bool. That's const because it doesn't modify the instances when it's called. Is divisible by. That takes a value, say k. It's also const. I think that's the header file right there. Except maybe you need the UML diagram. So you put that in there. Yeah, you're going to need to do that. There it is. We've got the header file already. I think that's it, right? Because if you look at the code, we have the constructor here being invoked. And you can see that the constructor takes an integer value. There it is. There's our constructor taking an integer value. And then we have an isPrime function and an isDivisible by function. Here they are defined right there. And that's all the functions that are needed for that test code.
Where do we define the code that the is prime and is divisible by stands for?
Okay.
Don't we have to?
Yeah, we need an implementation file. So we're going to have, if you look at what we have right now, we have ex1.cpp and number.h. Now we need to implement the functions in the number class. So it'll be number.cpp. But it goes in here. What goes up there?
Number.
Yeah, that's right. Very good. Thank you. Excellent. You have to include the header file to tell the compiler that this number class has been declared, and to tell the compiler what are its attributes, what are its member functions and member variables. So we have the constructor, and I'll use this form. This is the abbreviated form. That's good right there for the constructor. I'm using the initialization list here. I could have done it the other way. And just so that people don't get overloaded, that's a nice way to do it. That's the way I would do it for this one, but you need to learn this. So the member variable n is going to be set to the variable n that's being passed into the constructor. It's called, yeah.
What would happen if you flip the order on that? So you said n equals this n instead.
Yeah, that'll then that whatever is in the member variable n, that memory, which has been uninitialized, so it's going to be in a random state. Normally it's a 0, but it could be anything. That uninitialized memory will be copied into the local variable n, and the local variable n is not used, so that copy doesn't do anything. It's discarded when we return from the constructor, and the member variable n remains in an uninitialized state. Like I said, it's typically 0, but it could be anything. And we have the, is prime function. This prime is going to return true or false. That's a bool. Let's return true. And then that's just a stub. It's not what you need. And then you've got the number is divisible by. I'm going to use k there because it's meant to divide into n. It's not meant to replace n. Otherwise, if that was meant to replace n, I would use n itself. Like if it was set value or set number, then I would probably use an n there because that's good documentation, because it means that I'm going to replace that member variable n with the value being passed in. But we're not going to replace n. We're going to be trying to divide it by k, see if it works. Once again, this is a Boolean value. So these are stubs. Those are not full implementations. They just did it so that the thing would compile. And we have our three classes. Nope. Can someone tell me the mistake?
You didn't define it in the header?
Well, it is defined in the header. Oops, wait a minute. Look at it. It's defined right there.
Const?
Yeah. Good. Who got that? You got that? That was it. I declared a const there, but I forgot to define a const here. See that? So in other words, I was implementing a different function. Because I said it had the function I'm implementing has different attributes than the function that was declared in the class. That's the reason why it says is divisible by, and I'm going to cut this part of it out of line definition of, is divisible by does not match any declaration in number. See? Oh, look at this. It gives us a note. It helps us out a little bit. Member declaration does not match because it is const qualified. That's the first time I noticed that. Maybe at last quarter I was doing that too, but I would say a couple of years ago, you wouldn't get that message. It wouldn't tell you. Here it's giving you a hint. Now, if you're using an IDE like Visual Studio or Xcode, using a visual interface, we're using Xcode here. We're using the Xcode compiler, but I'm running it from the command line. So you're going to get, it's much harder to use the command line to catch syntax errors. It's harder. I wouldn't say much harder, because syntax errors is not a hard problem in general. But when you're using one of the graphical tools, these integrated development environments, IDE, that they're going to catch, they're so smart, and they're anticipating what you really want to do, and they're going to they're going to underline things as red, and they're going to point it out before you even try to do a compilation. They're going to be, sending off bells and whistles and bringing your attention to the error. But we're working at the command line, so we're like in the old days. Still, a lot of code is built on the command line, like when you download source code and you build a package that you're going to install. That's all done at the command line. But when you're doing a project and coding, you're almost always going to be using an IDE, so you'll get much better sort of assistance. But I don't want to cover IDEs. That's another thing, because we all have different systems, and I'd have to teach different IDE interfaces, and then it adds more complexity to the course. So I'm not going to get into that topic any more than this. All right, so there it is. So now this thing builds because we fixed it. And when we run it, assertion failure. Why did the assertion fail? 9 is prime. It said 9 is prime, return true. How come the assertion failed? Is this surprising that the assertion failed? No, because we're using stubs. So you got to figure out how to implement these. Can you implement that right now? It's one line. Just replace the question mark with an expression.
False.
Return false?
Return true if.
Well, no, you give me an expression that evaluates a true or false and return that.
Oh,
It's even simpler. Give me an expression that means n is divisible by k.
N mod k equals 0.
Exactly. Who said that? Good. You got it. Does everyone get that? N mod k is 0. So divide n by k and check the remainder that it's 0. Well, that means, so this expression, like this expression evaluates to true. This expression evaluates to true when n is divisible by k, and it evaluates to false otherwise. So we just, this is a compact way of expressing it. I don't need the parentheses. The other way to do it, we could do it like this. If n mod k is 0, oops, that's mod. If n mod k is 0, then return true, else, let me do it like this, else return false. This might be more readable for you, right? Is that readable? It's more readable than this line down there, isn't it?
that one's simple.
But in a couple of years, you're going to be writing it that way. And you wouldn't even think of writing it this way. Because you're going to be, if you do become a programmer or do a lot of programming, this becomes so natural to refactor and shorten it up to this that you'll just do it automatically. You know, this at your stage, this is what is readable. And you know, it's all about readability. So do it this way. Now, don't do it that way. I'm just telling you the future. I'm predicting the future for you, that this is how you're going to do it in the future. But might be how you do it now. And the same thing is, I should have changed these actually on the web page. This is hard for a lot of students to get. You know, I could have done it like this. This might have been more readable, right? This would have been more readable. You know, and if I had gone down like that, if I made those changes, so, you know, let's just call this prime and see and compare it to false. Make sure it returns false. This is probably the code that I gave you is I just haven't. I probably should go in there and change that and make it easier for people. On the other hand, if I put it like this, it makes you think about it as well, right? And is divisible by, is divisible by is easy. But is prime is a little more complicated because you have to do a loop. You do some kind of a loop. And in the loop, if a divisor for n is found, then return false. I'm not prime. Else return true. So if we pass through the loop, we check all possible divisors. From 2 all the way up to n minus 1. If any of those divide evenly into n, in other words, if n mod the divisor is 0, if that's true for any one of them, we're going to return false. Now, if we finish the loop and we don't return false, so if we return false, by the way, we exit the loop. We return from the function. So we're jumping out of the loop. So we never hit this last line. So if we go into the loop and the condition, that the divisor, that n mod the divisor equals 0, if that condition is never true, then we never return false. Well, that means we checked all the divisors, so we can return true at that point. That's the is prime algorithm that we have been studying. And it's almost the whole test, the whole lab right there written out. Left a little piece out. Is there any questions? Is that enough? Is it more clear today?
Yeah.
You got to practice. For the people that have already tried to do the work, it makes a lot more sense, right? When you haven't tried to do the work yet, don't wait to the last day. It's very hard for this stuff to sink in one night. You got to work with it over some time. And then it eventually sinks in and you acclimate to it. And then it becomes second nature. I mean, for me, it's just like breathing. So, and like I said, most programming languages and programming problems have this kind of structure to it. They have classes. All right, that's it for today.